It's 11x minus 10 over x minus 2 x plus 1. So they want us to resolve that fraction that you're seeing into a partial fraction. So now the question is, how do we go about it, solving that question? We have to solve this. We have to resolve it into a partial fraction. So when you look at this, you just look at your denominator that you have here. This is linear. And then when you look at the highest polynomial in our numerator, is less than the highest polynomial in our denominator. So therefore here we just go direct. There won't be anything like dividing. So what we are going to do here is, since this is linear as you're able to see it, it is just a, since we have two factors here, so we're going to have a and b. So a over n of this, so we're going to choose the best one, x minus 2 plus b over x plus 1. So when you look at the right hand side, if at all we happen to simplify that part, we identify the common denominator here. So the common denominator is simply x minus 2 multiplied by x plus 1. So this divided by that, we're going to remain with just this. So it is this multiplied by a. So it is a open bracket multiplied by x plus 1 plus this divided by that. This you cancel, just going to remain with x minus 2. So this is b over x minus 2. And this is equated to what? This part which is here. So 11x minus 10 over x minus 2 x plus 1. So when you take this, this side, or when you multiply this side by the reciprocal of our denominator. So the reciprocal of our denominator here is just multiplied by this part here. So it will be this, which is x minus 2 x plus 1. So what we do this side, we also do it even this other side. So when you multiply that, even this other side here. So it's a x minus 2 x plus 1. So I'm pretty sure you're able to see that this part and that part cancels, and then this part and that part also does what? Cancels. So we have remained with 11x minus 10 on our left hand side, 11x minus 10 equals to, and on our right hand side we remain with a bracket x plus 1 plus b x minus 2. So at the stage where it is, we can simplify. So when we simplify here, a multiplied by this, it is ax, a multiplied by 1 plus a, b multiplied by x, bx, b multiplied by negative 2, it is 2, negative 2b. We write it the way it is. So what we've reached now, what we are going to do next is we are going to identify the coefficient of x. We're going to identify the coefficient of x here. So when you say coefficient of x, coefficients of x on both sides. So what is the coefficient of x in this case? So I saying that the coefficient of x here, it's 11. So you say 11 equals to the coefficient of x here, it's a, and the coefficient of x there is b. So we are able to see that 11 is equals to a plus b. This is our first equation. That's equation number 1. Now let's identify our constants now. So our constants. So now constant in this, on this side, our constant is negative 10 equals to our constant here is a and negative 2b. So we now have two equations. We have equation. Remember, everything that we are doing here is to find the value of a and b. So that's what you're supposed to know. So this is equals to that. But now your task is to find what A is and what B is. And that's what we are doing here. So now that we have established two equations, it's just a matter of using simultaneous equation to find the values of A and B. So this question, this one, as you can see, we have A, so you can just introduce a minus there. So 11 minus 10, this will give us a 21 equals to A minus A, it's a 0. B minus 2B, it is 3B. Then over 3 over 3. This implies that our B is equals to 7. So the value of B is 7. So now that we found the value of B, I'm sure it's easier for us now to find the value of A. So we can either pick equation 1 or equation 2 to find the value of A. So let's pick equation 1. So equation 1 is 11 is equals to A plus B. Where there is B, we put a 7. So we're going to have 11 is equals to A plus 7. So 11 minus 7 is equals to A. So our A here is 4. So we have found the value of A and we have found the value of B. But we are not ending here because we are not looking for A and B, but we are trying to resolve this into a partial fraction. And for us to resolve this into a partial fraction, it was a matter of us finding A and B. So now after we've found the value of A and B, you just replace in that equation where there's A, you put a 4, and where there's B, you put a 7. So that's what is expected. Let's do this. Just positive 8. So our solution is what I've said for there. That's our solution. Unless there's a question before we move to question number 2. Any question? Okay, since you guys don't have questions, let's go to question number 2. Question number 2. Solution x squared minus 18x plus 5 over x minus 1 x plus 2 x minus 3. So when you look at that question that is on the board, similar to question number 1, isn't it? It's also similar to question number 9, to question number 1, because this is also linear. As you can see, we have these 3 factors here. These are also linear. When you look at the highest power there in our numerator is 2, and the highest power here is going to be 3. So this is just a matter of it's a matter of us going direct, no need to divide. So you can only divide when you happen to find the highest power in the numerator to be equal to the highest power in the denominator, or you happen to find the highest power in the numerator to be bigger than the highest power in your numerator. So when you look at this, when you multiply this x to give us x squared multiplied by this x, it will give us x to the power 3. So mean that here the numerator we have the highest power which is greater than the one in our denominator, sorry. We have the highest power which is greater than the one that is in our numerator. Therefore, we just go direct. But if I tell you had a situation whereby in your numerator you have x squared, and then even in the denominator you have x squared, something like the highest power. So here you divide. Or if I tell you find something like this bigger than what is here, you also divide. That's when you start the process of resolving to partial fractions. So in our case, it's just a matter of going direct. So let's start. Since it's linear and we have three factors, so we are expected to have A, B, and C. So A, B, and C. So this is equal to A over, we can decide any one that we can pick, plus B over X plus 2 plus C over X minus 3. So next, if we do the same, so remember what we did previously, we had to find the common denominator this side, and then we had to find next, we had to find the reciprocal to cancel. But now we know to say, even if we do that, the next stage is that stage whereby if you just do this stage, where you identify first of all the common denominator in this case, which is X minus 1, X plus 2, X minus 3. So this divide by that, we are going to see that this and that cancel. We are just going to remain with this part which is here. So it will be this multiplied by A. So it is A, open bracket, X plus 2, X minus 3. We move to B plus this divide by that. So this and this cancels. You're going to remain with this and that. So it will be B multiplied by X minus 1, X minus 3. Lastly, C. This divided by C, you're going to remain with those two factors. So remain with X minus 1, X plus 2. So you're seeing that when you now you multiply this with this reciprocal, you're going to find that this part is going to cancel with this part. So therefore, we're just going to remain with it, that part and this part. So I'm just going to erase this since you've seen what has happened. And then we're just going to remain with X squared minus 18X plus 5. So to remind it. So next, when you reach at this stage, you can either simplify it, or you can even let X be equals to 1. So that when you let X to be equals to 1 here, you're going to get a 0 this side. You're also going to get a 0 this side. So you're just going to remain with this part and that part which is there. Or you can expand it and then start using the coefficient one, whereby we start finding the coefficient of either X3, X2, up to the end. So it's up to you guys to decide. So now in this case, looking at time, what I will do myself is, I'm going to eliminate this and this, so I can just remain with this. So how am I going to eliminate? Just by letting X to be equals to 1. Why 1? Why didn't I pick any number? Because when we look at this, we have X minus 1. So if I want something that will give any of my factors a 0. So now if I put a 1 here, I'll definitely get a 0 this side. I also get a 0 that side. So this part will be eliminated. I'll just remain with that part. So X is equals to 1. So wherever there is X, just put a 1. So this side, when we put a 1 where there is X, we're going to have 1 minus 18 plus 5 equals to A. When you put a 1 here, you get a 3. So you get a 1 plus 2, which is 3. So here we'll get a 3. Next, when you put a 1 here, it's 1 minus 3, which is negative 2. So we have 3 multiplied by negative 2, which is negative 6. So negative 6 multiplied by A, it will give us negative 6A, negative 6A. This side here, when you put a 1 here, we'll get a 0. 0 multiplied by this part, we'll get a 0 here. We'll do the same here, put a 1, we'll get a 0. So already you've seen that the two terms there have vanished. So we just simplify this part. So 1 minus 8, 1 plus 5 is 6. 6 minus 18, it's negative 12. It's equals to negative 6A over negative 6 over negative 6. So our A in this case is 2. So we found the value of A. A is equals to 2. Again, I can remove this. After finding the value of A, I can again let X be. So here I want to make this a 0. So for me to make this a 0, it's just a matter of letting X to be equal to negative 2. So negative 2 plus 2, it will give me a 0. So let X to be equal to negative 2. So wherever there is X, we put a negative 2. So we start from here. Negative 2 squared, it will give us a 4 minus negative 18 multiplied by negative 2. That's positive 36. So get positive 36 plus 5 equals to, we come here. When you put negative 2 here plus 2, it will get a 0. 0 multiplied by this. So we're going to have a 0 there. We come here. When you put negative 2 here, we are going to have negative 2 minus 1, which is negative 3. So this will give us negative 3. What about here? Negative 2 minus 3, which will give us negative 5. So we have negative 3 multiplied by negative 5, which is 15 multiplied by B, which is 15B. The last part there, when you put X equals negative 2, it will be negative 2 plus 2, which is 0. So this will give us a 0. So you have seen that this part and that part have vanished. So we just remain with this part. So we just simplify here. 4 plus 5, it's 9. 9 by 36, that's 45. So 45 is equals to 15B over 15 over 15. So 3 is equals to B. So B is equals to 3, A is equals to 2. Now let's find the value of C. So for us to find the value of C, make sure that X is not equals to negative 1, is not equals to 1. X is not supposed to be equal to negative 2. So we can just say X equals to 3. So at least if we make this a 0, we also make this a 0. So when X is equals to 3 here, let's just do it here. Or let X to be equals to, how are you?
I'm fine.
I'm blessed and highly favored. So now, when we let X to be equals to 3, we're going to have, we'll start with this which is here. 3 squared, it's 9, minus negative 18 multiplied by 3. So I have 18 multiplied by 3, 54. So it's 54, but it will be negative 54 plus 5 equals to, when you put negative 3, when you put 3 here, we'll get a 0. This will give us a 0. 0 multiplied by this will be 0. We come here, we put a 3 there. 3 minus 3, it's 0. So this will give us a 0 as well. Now we come to the last part. 3 minus 1, it's a 2. And 3 plus 2, it's a 5. So 2 multiplied by 5, it's 10. So 10 multiplied by C, it's a 10C. 10C. So 10C. So now we have 9 plus 5, that's 14. 14 minus 54, that's negative 40. And 10C, then we divide by 10. So I have negative 4 is equals to C. So we have A equals to 2, B equals to 3, and C equals to negative 4. But remember, we have to replace the values that we found on the expression that, on the equation that is on top. On equation 1, let me label it as my equation 1. So now, in conclusion, x squared minus 18x plus 5 equals to x minus 1, x plus 2, x minus 3 equals to, what is there? We put a 2 over x minus 1. What is B? We put a 3, x plus 2. And then what is C? It's minus 4 over x. That's our answer. That's our answer. Any question?
Madam,
Yes.
Madam, what if
Question number 3. Ten x squared minus 73 x plus 144 over x minus 4 equals to squared. So when you look at that question which is on the board, first thing, like I told you, look at what you have. Look at your highest polynomial in the denominator, and look at the highest polynomial in our numerator. So when you look at our numerator here, the highest polynomial is 2, and then it's raised to the power 2, and then in this case, when you square x here, it will be x squared multiplied by this x which is outside, so it is x to the power 3. So we are saying that this is just okay, there's no need of us to start dividing. So here we'll go direct. And then after we've established that fact, now we'll look at our denominator here. Is it linear? Is it quadratic? Is it a repeated root? You have to ask yourself some of those questions. So when you look at this part here, this one which is here is quite all right, it's linear, but this part which is here, this is repeated root. So when we have repeated roots, how do we express our values? So when you have repeated roots like that, you have to know to say, if we, let's say for example, you have 1 over x minus 4 squared like that. So here it will just be a over the inside part. So now this inside part is linear. So it's the way we express linear function. So it is a x minus 4 plus b over this part which is here now squared, x minus 4 squared. So since the highest part, since here what we have, the power factor is raised to the power 2, will end just there. But if at all it was something like this, if it was x minus 4 raised to the power 3, like this, we would have started with x to the power 1, x to the power 2, up to x to the power 3. That's what would have ended. So if at all it was like this, we would have had 3 values. We would have found the would have had 3 fractions: fraction for a, for fraction for b, and fraction for c. If it was like this, so it would have been a over what is inside here. Since it's linear, just say x minus 4 plus the next part. It is now this part squared, so it is to be b x minus 4 squared plus c over, since it is up to 3, so the last part will be x minus 4 raised to the power 3 like that. So similarly, that's what we are going to do on that question that we have, just on that part. But for this part, you are seeing it, it's linear, so it will be a over this and then plus, you start from here now again. So having given you that background, I'm sure we